Hi, so I'm going to do a quick rundown of my TI series, doing time series using PyCaret. Um, so at the very beginning, notice that I have to force fix a version of Desk. This is because in 2025, January release, Desk removed its data frame module, which will cause some compatibility issue with PyCaret later down the line. So at the very beginning, I'm pinging the version to an older version from 2024. Okay, so for this assignment, I'm using the PyCaret download dataset, which is dataset of the number of downloads for PyCaret, I guess, um, running from 2021 July to October on a daily basis. So yeah, here I'm just plotting data. Uh, the first step when dealing with time series data is, yeah, to make sure the data is the data column is actually of type date time. So originally the type of the data column is object. Sometimes it could be string. You have to manually convert it to date time. And you have also need to set it as the index. So that way it works gracefully with the automation, the model automation. Um, for example, you can, if you convert the data column as date time type and you set it as the index, you can do some nice things, uh, such as, cut off the original data into a train and test data set uh, by just passing it uh, a date time string. You know, this will only work if you first convert it to a date time type and you set it as the index. Otherwise, it won't work. Okay, so we have cleaned up the data set. Now we can move on to model training. So once again, PyCaret is a very convenient and low code uh, library to use. So we simply import the time series module from PyCaret and we do the setup. Now, we set the target, as the total column. There are some unique parameters when it comes to time series. For example, FH, which means forecasting horizon. So in this case, essentially is how many data sets ahead I'm trying to predict. So in this case, FH12 means I want to predict the next 12 data points. And since our original data set is on a daily basis, this means I want to predict the next 12 days data. So we set up and we plot it. Now, I didn't know it before. I was trying to manually do the training and testing data set split, but apparently uh, the setup code already uh, does the train test split for you, as you can see. So I'm just going to use their built-in train test dataset split. So, okay, here I'm just trying to pick the top four data by performance. I think let me see. So the apparently they are using some kind of metric to rank the top four. I do not know. Um, but anyway, So we got the top four. I want to see how it works. So, oops, let me see. Huh, interesting. So I was trying to show the, oh man, I was trying to show it in full screen. But what it does is that it essentially it gives you a very nice looking um, plot. So remember, we were using top four models, right? And this is the train and test cutoff. So it it's able to, when you call the plot model function, it's pretty intelligent. It picks up top four models and uh, individually plot them. And they actually, I was trying to show the legend here, are actually spell out what each of this plot corresponds to the model. Anyway, so here I want to pick the single, I also want to pick the single best model using matrix MAE. So I'm just calling this sort on that. Um, and I can plot this one single model. And looks like it's the theta forecaster. Interesting. So it has the lowest MA. Yeah, I think so. So here when we do compare models, I think by default it's picking the MAE as the metric to use. So as you can see, when I pick top four, it's actually picking the top four models with lowest MAE. Yeah. So if I pick a different, if I set a different metrics here, uh, I can have a different ranking. I can pick a different best model. So anyway, I'm just showing that PyCaret is offering a lot of flexibility. So this plot is just like um, what what the theta forecaster would predict for the test data set. It's very interesting because it gives you a range as well as a mean. So I guess that's how the theta forecaster works. Here, so I have already have the top four. I'm creating an ensemble model. Basically, let this four models, top four models, to take a vote and get a final model out of this ensemble. So here I'm plotting how the ensemble uh, would work on the test model, sorry, on the test data set. So one thing I was reading up the documentation and I realized the difference between, so here you got the final model after calling finalized model, right? And the difference from this versus like the model we got here is that the model so you can have this blender as this ensemble model, right? At this point, it's just a model that was trained and fitted based on the trained data set. Once you call the finalized model, it will try to fit the model with the entire data set. So it's training data plus test data. So that's what this function does, essentially. Uh, yeah, and here I can also try to plot it. Remember, we said FH, which is forecast horizon. I can, once I have this model, I can try to make it to predict, to make predictions for further data points that is not in the original data set, right? So here I'm trying to make it to forecast the next 24 days. So as you can see, this is the original data set. It pretty much ends on October the 17th. But here I'm asking it to make 24 more days. So, sorry, 24 more days from the training set. So the time horizon expands. Yeah, so that's pretty much it. I'm here saving the final ensemble as well as the single best model, which is Theta Forecaster. And that is all of my rundown of the time series code. Thank you.